Check. Oh, shit. Oh. All right, welcome everyone. It's been a long time since any of us have sat in front of a crowd and did a talk, so give us a little grace here. So welcome everyone to our talk. Today we're going to be talking about using Terraform and AWS to create things on the fly. We're going to tell a little story as well to explain how we got here and what we're doing, and then we'll actually go ahead and create some new things inside AWS. You guys will all be able to participate. As long as you have a GitHub account, we've got some AWS accounts that everybody will be able to use, and we've got some code that you'll be able to follow along with. So for introductions, hi, I'm Aaron Junod. I am CTO of Z Suite Technologies. Z Suite's mission is to help banks better serve some of their most valuable customers. We have a escrow system and a couple other systems that we're going to talk through today. We have a few other people presenting today. We have Eric Loveland. He's one of our platform architects. He's here to describe the architecture. And we've got Dan Cushman. He is one of our system architects. He's here to actually walk us through all of the activities. And while we were supposed to have Keith, he is unfortunately at home with a breakthrough COVID case. So that is a shame. So he would have been here as well talking through. But all right, so there are some prerequisites. Because we're going to be doing things in AWS, there's a few things you're going to want to do to get cooking now. So by the time we get to the later part in the talk, they're ready for you to actually work. And with that, I'm going to hand it over to Dan real quick, and he's going to show a demo of what we're going to do so you have a sense of it, and then we'll go right into setting it up.
All right. So yeah, just wanted to kind of kick us off with a little bit of a preview. What we have here is a Argo CD running in an EKS cluster, and we have deployed the Moov Watchman app and API. So this is what the lab is going to consist of today. So we'll be spinning up an AWS VPC and EKC cluster, and then we're going to use Terraform to install Argo CD onto it, and then we're going to deploy an app using Helm charts in a separate repo. So maybe to start off, has anyone used Terraform before? All right. And how about Kubernetes? All right. And are you guys familiar with Argo CD? Heard of it? Okay, great. Well, I'll, we'll kind of give some general concepts and background for all these things as we go, but feel free to ask questions as we walk through things. So this is where we're going to end up, and to start things off, though, we need to set up some accounts. So elove. So I think that, actually, should they find this repo first?
Sure, that would be great. Yeah, so if you'd like to, you have a bit.ly.
Yeah, there's a bit.ly link. If you go to bit.ly/ZSuiteTech, I think it's in the deck. You go there, /ZSuiteTech. So if you go to that URL, it'll bring you to the repo.
Cool. So, well, let's make sure everybody gets there.
Also, if anyone has any problems or questions, just raise your hand and I'll come over and help.
Yep. Junod is our runner today. Okay. So we're going to start with navigating to the AWS event page. So if you actually have the GitHub repo open, scroll down past where the files are. We probably should have linked directly to the README, but that's okay. And then click on the link there to go to the AWS event page. And then you'll see the next step down in the repo. You're going to just copy that code and paste it into the text box on the Event Engine page. You can do it. And then click.
Well,
accept terms and conditions. Okay, so now this is going to allow us each to get our own account in AWS. It's a temporary account. And you can either log in with your Amazon retail account or have it email you a one-time password. Amazon recommends the one-time password option, although I did test the Amazon option this morning and it worked okay. So either one is fine. So I'll let you do that. So just click on one of those and it will, if anybody has any issues logging in, but it'll bring you to this dashboard once you get the code and then put it in or log in with your Amazon account. So we'll wait just 1 minute for that.
Do you want? You want?
I can't be bigger than I meant it. Okay. Anyone not logged in? Great. All right. So moving on to the next step, we're going to click the AWS console button. And then click the Open AWS console.
Do we need to copy these? Or?
No, that's later.
Okay.
Yeah, we gotta get the Cloud9 set up first. Okay, great. So for those that aren't familiar, well, actually, maybe we should have asked, how many people here are familiar with AWS, or are not familiar with it but have used it before? Oh, great, most of you. Okay, so you should know the management console. So what we're going to do, just to make sure everyone has consistent setup, is we're going to create a Cloud9 instance. What Cloud9 is it's a online editor, basically, that runs on top of a virtual machine in AWS. So if you saw what Kushtan did, he went up to the search bar at the very top, typed in Cloud9. It brought up Cloud9 as an option. And then when you get to this page, please raise your hand if I need to slow down. You're going to click this Create Environment button. All right. You can name it whatever you'd like. Don't do that. Actually, don't name it that, because the repo name is that, and it gets very confusing if you name it the same thing as the repo, because it's hard to see in the tree view in Cloud9 which one's the repo and which one's like the root of the project. So, all right, so no descriptions required. You can hit next. We're going to leave the default settings for all of these things, except for instance type. We're going to change that to T3 small just to make sure we don't have any memory issues. We think it should be okay. So, and then go ahead and hit next step. Okay, this is just a review, so you can hit create an environment. All right, this actually, for me, when we did this test yesterday, it took about 45 seconds, so hopefully it goes nice and quick today as well.
Anybody that is following along have any issues? Everybody following along so far? Excellent.
There we go. All right, so now we're in Cloud9 editor, and I like to no, we're not. We'll put in full screen in a minute, but what you can do is you can, just to give you a little overview, I mean, it's actually very similar to if you're using something like Visual Studio Code. It works very similarly. In fact, a lot of the keyboard shortcuts and things work similarly as well. But you basically, on your left-hand side here, you have your file browser at, right underneath the search bar, or the search button, and then some Git tools on the second one. And we're actually not going to use the AWS tools for anything today. So the next thing we're going to do is run a script in the console to get everything kind of set up. So what you want to do first is go back to your event engine page, and then where it says Mac or Linux, just click the little blue button, and that will copy all that text to your clipboard with no visual indicator, I guess. And then you're going to paste that into the console at the bottom of Cloud9. Just Control V or Apple V. And hit enter at the end because it doesn't complete the last line. Everyone good there? All right, great. So now we're going to clone that Fintech DevCon repository. If you'd like, you can go back to the instructions, and there's kind of commands you can copy. Oops, except that one's wrong because I changed it from one tool to another. So you're actually going to want to copy this oh no, not that one either. Shoot. Sorry about that. Yeah, so if you go into the GitHub UI, no, that's it. Okay. Click this code button in the upper left right-hand corner, and then click the little clipboard icon, or make sure it's set to HTTPS, and then click the little clipboard icon next to the repo URL. Now, if we go back to Cloud9, I'm going to type git space clone, and then paste that in Control V, or you can paste that way, but you have to let your, and hit enter. Okay. Now we're gonna, everyone good at that so far? Cool. Now we're gonna go to the Fintech DevCon folder. So CD Fintech DevCon in your, and you can use tab completion. So just type CD fin and you'll get it. All right. Now we're gonna run our setup. So it's, and just to describe what it does, so you know we're not like messing with you. Basically, it's going to go remove some unnecessary software that we're not going to need for the demo today. It's things like PHP and MariaDB. It's going to install the kubectl Kubernetes command line tool, and then pull down an additional repo, which is where our Helm charts live. So you're going to run /se, and then you can hit tab, and it should complete to setup.sh, and hit enter. And eventually, it's going to prompt you to log into GitHub, because what we're going to do is actually fork that Helm charts repo into your own repository space in GitHub. That way, you can actually make changes and then see them reflected in the environment that we're going to be setting up. So wait till it gets there.
Should I already have it forked? Should I rename it? Yeah.
Oh no, it'll if you already have it forked, it'll still work.
All right.
Okay. So we'll give it a second just in case not everyone's gotten here yet. But basically, we're just going to follow the instructions in the terminal here. So copy that one-time code, and then hit enter. It's going to say, oh, we can't find a browser, which is fine, because Cloud9 actually will turn links into clickable links. So if you click on the link that it shows at the top, which is the GitHub login device, you'll need to make sure you're logged into GitHub. Oh, you're in private, that's why. You have your YubiKey on you? Do you want me to log in as mine? Oh, there you go. Demo demons. Okay, so now the code that you should get the screen. Anyone not at the screen or further if you're following along? Okay, so just go ahead and paste the that one-time code that was in the terminal into that screen and click authorize. And by the way, this thing that is logging in here, just so everyone is aware, it is a command line client that's owned by GitHub, created by GitHub. So, yeah, don't worry about the client that it's running. Okay, so I'm gonna assume everyone's there. Raise your hand if you're not, and Junod can help. Now let's go back into Cloud9, and we can actually full screen at this point because we don't need to jump around at all. And just press enter to continue. Okay. And you should get that it forked the repo, which most people probably don't already have forked, but if you did, then it'll say it already exists. All right. So I think we're ready for Junod to continue.
We'll do.
Oh yeah, you want to actually run the.
Yeah.
Okay.
So now that we've got the repo pulled down, if you look at the README, we're going to do the first step of kind of kicking off Terraform to start provisioning the cluster, which takes around 10 minutes. So we want to get that going.
Yeah, if you right-click on README in the view.
Yeah, if you right-click there, you can hit preview, so you can easily see the formatted markdown and not have to try and do that mentally. So if you scroll down to the workshop, we'll start off with creating the EKS cluster. Is the bucket, is this variable done, or they need to start there? All right. So the first step is going to be creating an S3 bucket that we're going to use to store some of our state. So you can copy that command and paste it in. Oh, looks like there's a, sorry, there's
Extra, yeah, there's an
errant single quotes there. So just, oh, we were missing at the beginning?
Yeah,
Oh,
so
yeah.
there's just an extra back tick at the end, so you can delete that. All right.
All right, so yeah, let's set that name. Uh-oh. All right, we tried to set the name based on your GitHub user, but why doesn't everyone just throw in some random thing at the end there, just because our bucket names need to be unique. So I'll just put Kushdan. And now that we have that variable set, we can kick that off and create that in S3 by pasting the next command.
Is that big enough for everyone to see, by the way? Just want to make sure. We can zoom it a little bit if we need to.
Better? All right. Didn't work. All right. So once that's there, we can initialize our backend config with that same variable. And what this is going to do is it's going to initialize Terraform, which is going to pull down all of the modules and providers that your Terraform project uses. So if you look at the main TF file, that's kind of the main Terraform script, and you'll see at the top there's these sections that kind of define those things. So we'll go into that a little bit more once we kick this off. So now that we've pulled down those dependencies, we can run this apply command, which is going to actually go out and try to make the changes that this Terraform script has defined. All right, and it'll show you a little review step before it does anything, and you'll see a large number of resources that you're going to create. So we are cool with that, and it's going to get started. So it'll just, show you its status, and it should take around 10 minutes. So anyone have any issues running that? Is anyone able to run it? Good? Sweet.
Yeah, so while this cooks, I'm going to tell a little story on how we got here and what we're doing. So if anybody is trying to follow along and having any issues while I'm talking, please raise your hand and we'll come and help you, get you caught up. If you missed the beginning and you want to catch up, we can help you with that as well. Just let us know. All right, a little bit on Z Suite before, so you can understand why we've created what we've created. So Z Suite as a company came out of Leader Bank's Innovation Lab. Leader Bank is a bank in the Boston area, and in 2015 they decided they wanted to bank more landlords and property managers. Instead of the traditional means of marketing to landlords and property managers, Leader Bank created two platforms to manage the rent and the security deposits for those landlords and said, hey, you can have this if you bank with us. It was a really successful strategy. At the time, Leader had 2 people dedicated to the administrative aspects of running these expensive programs. Now, Leader Bank has 4 people on the team growing those aspects of the business. It's really exciting. So much so that some of their competing banks also wanted to get in the action. And Leader started licensing those products out and got to the point that they needed to spin out a separate company, and that's what Z Suite is. So Z Suite was spun out with the mission of helping banks better service their most valuable customers. So with that, we were marketing, go ahead and go to the next slide. We were marketing our property management platform to a number of banks and all across the nation. It was going really, really well. And then, well, the pandemic hit. And the biggest sales factor of our Z-Rent and Z-Deposit platform was that it would get you cheap deposits. And no bank was interested in cheap deposits when they could get unlimited free deposits from PPP loans. So every bank in our pipeline said, we love your product, come back in 2 years. As a young startup, having every bank pull out of your pipeline, it's difficult. Like, what do you do? So we knew our company mission was not to service property managers only. So we took that opportunity to start to work on our ultimate vision, which was the escrow. When we were presenting our property manager software to banks, many of the banks were like, hey, do you do this for municipalities? Do you do this for lawyers? Do you do this for exchanges? They had a lot of use cases that we weren't handling with our property suite. So we found 5 banks that were still interested enough in this problem to actually design and build a solution with us. So last June, we had 5 contracts with 5 banks to build a general purpose escrow system. We had no requirements, we had no staff, but we had a contract and a deadline. You guys have all been there, right? It's great. So what we did was start to figure out exactly what we had to do to meet our objective. Go to the next slide. So one of the things we needed to do was make sure we were actually solving the problem. So we immediately started an immense set of user interviews. And we spent about 9 months interviewing all of the stakeholders. We interviewed banks, we interviewed municipalities, we interviewed lawyers, we interviewed banks, we interviewed brokers, landlords, banks. We interviewed everyone, but really the banks were the big feature here. When you look at our property features before, they were all about the landlords, where now we were building a platform to help the banks manage these. So we spent a lot of time talking with them. So much so that many of them were like, we've never been involved in a project like this where we actually have this much input into it. And it really made us feel good because they were validating every step along the way, making sure that what we were building was actually going to serve them and be able to help their most valuable customers. We had monthly meetings with all of them, and it ended up being a recap because they all knew what was going on by going through our user interviews and our deep process of really making sure we were building what they needed. So, go to the next slide. Fintech positioning. With zRent and zDeposit, we found when going to market, we were able to get a lot of interest from banks saying, hey, we can bring you from signature to lit up implemented in 30 days, 2 weeks. Like, we've really wanted to be able to go from initial pitch to launched as quickly as possible. And our banks loved that. They're used to long projects involving lots of different vendors. So when we built zEscrow, we wanted to make sure that we could approach all of the banks and say, we can have you lit up in 30 days, in 60 days, no integration, or very little integration. We did that with files. One of the other questions we've all had as well, like, we've been working with banks for a long time. I've gotten this question more times than I can count. How is my data separated from other banks in your platform? And no matter how good the technology is, when you've got data sitting next to it and you have to explain to a compliance officer how that data is separated, that's a difficult conversation. So it's not in our platform. We decided early on in the architecture that we were going to uniquely provision infrastructure for each one of our tenants. That means if there's a bank that has 2 tenants, a staging and a production environment, they're both completely separate, encrypted with just keys for that environment. Now, on every security review, just put your data is physically separate. And that's a lot of what we're going to talk through today. The infrastructure that allows us to manage physically separate infrastructures for all of our banks through a single set of code. Is it perfect? Nope, it's not. On provisioning wise, we're probably at about 80% automated, but the most important thing is on updates after that, where we really need to iterate and show the banks that we can move. That's fully automated. So as we move forward, we can chip away at some of the initial setup pains that we still have while continuing to iterate incredibly quickly with our customers. And next slide. Yep. And a little bit of a disclaimer. There's a lot of different technologies that have been used in our stack. And we feel we've made a lot of great decisions, but we've also made some poor decisions. We've already had to pull out a couple technologies that we chose for various reasons. So while we're going to show you a lot of what's going on in our stack, please take these all with a grain of salt. Your results may vary, your circumstances may vary, these technologies may not be right for you. All right, so a little bit about the architecture. I'm going to say something that may offend some of you, so I'm going to apologize in advance. When you sit down to start designing a system with a team for the first time, and they're talking about microservices, be a hero, talk them out of it. Microservices are wonderful, they're great, but they're also very, very expensive. It is far more expensive for you to marshal data across a barrier than through memory. And when you're talking about 6, 8 subsystems, that can be very, very expensive from day one. You might not need it yet. So what we actually did is we designed microservices. We know eventually we're going to need to have the scale and the isolation to be able to scale individual aspects of our platform. But we didn't want the cost of that. So we implemented it in a modular monolith. So that means all of the designs are still the way they would be for the microservices. All the contracts are big, chunky contracts. We don't have one system going directly to the database of another. The contracts between each one of them is still designed like they're different systems, but they're not. When I call from one system to the other, it's in memory. So when we identify that a certain section needs to come out, we don't need to analyze how to pull it out. All we need to do is start to build the abstractions and pull it out and put a transport in front of it. Another way we were able to do this is, is by buying as much as possible. We really wanted to focus on our 20%. So a great example is with our original property manager suite, we built our own e-sign. It was expensive, and it was a pain. We didn't want to do that again. So with zEscrow, we used DocuSign. Same thing with authentication. We use Auth0. Like, we wanted to pick the best partners for these that can scale with us and give us the right cost structure, so that when we go to the banks and we're like, hey, we're e-signing in DocuSign, they've already got a contract with DocuSign. We're using our authentication with Auth0. They may already know about Auth0. And if not, Auth0 is big enough that I can hand them SOC documents and make them happy about it. So really choosing your third-party options wisely is incredibly important. So as I mentioned, one thing to say here too, Steve Brown yesterday from Autobooks, he made a really good comment that struck with me. One of the internal tenets we use in designing everything, he actually put a name to yesterday, and I'm going to steal it from him and use it all the time, and it's good enough to iterate on. When we're designing and building things, while we try to take a vision and look at how do we want to build this for our ultimate vision, our first deliverable is always good enough to iterate on, so we can figure out, is this right, and then move it from there. That way we don't have to back out things where we maybe went a little bit too far. We'll wait to go that far until we see the stress cracks. All right, so as I mentioned, we had a year to go from contract to production. No requirements. First thing we started to do is build our requirements. So while the team is off doing the user interviews, the tech team, the product team is off doing the user interviews. The tech team is deciding, how do we actually make this happen? So the first thing we did was create a set of C4 diagrams. Everybody loves architecture diagrams, and we did a little bit of research and found that the C4 framework for architecture diagrams is a great framework to help organize the different granularity layers of your potential system. So I highly advise you guys look at this. We put together these that described where our systems sit in the context, where all our containers are, what each container would look like, and we were able to take these diagrams and talk with our stakeholders, our internal team, and make sure that we're at least conceptually on the right page of what we're trying to target for. While the product team was off refining requirements, we then analyzed all these architecture diagrams and identified things that we could move on without requirements. So for example, we knew we needed branded statements. I don't need that many requirements to start picking a PDF generation library and building the code that will let me automate that. We knew we needed e-sign, so we can go find our e-sign provider, start to build the integration of that. Find the things that we could do, even though we didn't have our full requirements yet, and start to put that stuff in place. So our project was actually built into, the project was structured with 4 deliverables, one each quarter of the project. Our first deliverable really just let people log in. No real banks, no nothing, because we didn't have requirements yet. We're still figuring out what we're doing. The next release, 3 months later, had a little bit more accounts. We started to know a little bit more about what was going on, but it still wasn't functional. It wasn't doing anything close to what the banks needed. By the 3rd release, you could create accounts. You could virtually move money. We weren't moving money yet, but you could see what it would look like to move money. The banks could really understand what this was going to look like. And by the 4th release, we actually had a few of the bank's customers using it and starting to give us feedback on what they felt like using it. So again, went from idea to managing money in less than a year. So one of the things that we also created is our logo soup. So anybody that has had to talk with banks about your platform and get some buy-in has been through a process like this. Like you're sitting on the phone with the tech saying, here's what we've got, do you want to use it? Having gone through a number of those, we needed a guide, and next slide. This is the diagram that we talk through with all of our banks. Actually, during our sales process now, as soon as someone signs an NDA, we bring them into a technical conversation. So we describe to them what the program does, so all of their tech people understand what they're getting into, what the infrastructure looks like what the integration looks like, so they understand how to implement our product. And then we walk through what our product is under the covers. And we let them see, we are a API-first platform. All of our capabilities are built in our GraphQL API first, and then utilized through different clients. Our API is GraphQL, platform.net, database down here, and then we let them see how we build, deploy, and operate, because they're very different aspects of our platform. And this really helps the banks get a good feeling of what we're doing, and honestly, gives them a lot of confidence. A lot of them just stare at this for a little while, and they're like, I have a really good idea of what's going on. Thank you very much. But with that, I am actually going to hand it off to Elov to talk through a little bit more of what's in Logo Soup and why it's there.
So when we were discussing what technologies we wanted to look at, when we were talking about the build versus buy argument, we came down to the fact that we basically want to be, as Junod mentioned, we want to be kind of building the thing that is our bread and butter, and we don't want to be worrying about, building tons of other things. So we said, okay, when we're evaluating vendors to, kind of contribute to that logo soup, what do we want to look for? And the two main things in that regard were they had to be cloud native, meaning that we could, and actually support cloud native is probably a better way of putting it, that we could basically have our apps deployed in any sort of instance, any cloud, even on-prem, and still be able to use their services no matter what we chose as our deployment mechanism. And that we didn't have to jump through a lot of different hoops to leverage their services. The other thing that we tried to look for is that they were a SaaS platform. We didn't want the challenge and the operational complexity of running, even if it's third party, running it on premise. So we kind of geared towards SaaS providers as much as possible for those third party tools. And then we wanted to make sure that they had an API or some other mechanism for automatic provisioning. So infrastructure is code, configuration is code, because given the fact that we're provisioning for every new partner we bring on, we couldn't afford to do a lot of manual setup for each of those partners. So those were kind of some of our guiding principles when looking at tooling. And then even the tooling for building our own platform. We chose Kubernetes because it is geared around configuration as code. We chose Terraform for the same reason, so that we could have that flexibility to deploy as quickly as possible. Next. Then the other thing that we really focused on, because obviously, everyone here knows when you're dealing with banks customer data, security is of the utmost importance. So we started from the mindset of zero trust at the start, and basically we used we had to make sure that basically everything that we were doing had the ability to only provide just enough control, like access for the system, for the users, that they could accomplish their tasks, but not have to cross the boundaries into other banks and not have to, give more permissions than they actually need. And then in terms of reliability, we, for both our own internal platforms and external platforms, we had to make sure that they had high availability operations, meaning, we could implement replication on our side, they could implement replication on their side to make sure that we could stay running, even if an AWS region goes down, something like that. Next slide. And then the final kind of concept that we approach this with is the concept of GitOps, which is something that has been kind of brewing for the past, probably 5 years or so, but really came to the fore about 2 years ago, maybe 3. And it went very much hand in hand with Kubernetes. Because Kubernetes is a platform that is designed to be driven by configuration as code, taking the concept of DevOps, which is the concepts around DevOps. So basically, the ability to get fast feedback, the ability to basically drive your code into production through your Git repository. The idea was take those same ideas and apply them to your infrastructure as well. So, so basically what GitOps allows us to do is use Git as our review and promotion mechanism, not only for code in the traditional way, and I should say review, promotion, and build and deploy trigger as well. So not only for our code, but any changes that we had to make to our infrastructure could also be done through a code review process, or go through a code review process, and then we use GitOps in general as a concept, uses branches as a mechanism to promote things between environments. So when you're ready to go from dev into staging, you open a pull request, and if the code's already been reviewed, all you're doing is just having a discussion as to whether the team is ready to go with the code as it is today. And then you open another pull request when you go into production, so you can have that discussion. Especially with a distributed team, it's very nice to be able to use the pull request concept to have those discussions and review points for when we're promoting infrastructure changes as well. And one other thing, like kind of tying back to DevOps in general, the idea was always to bridge development and operations to get them to, basically be more collaborative, and everybody's pushing for rapid delivery. Well, when you're a team of 4.5, I would say, because Junod, CTO, is not really involved in the day-to-day operations, but when you're basically a team of 4 people trying to deliver software, and you're kind of a small startup, you can't necessarily afford to hire a bunch of operations people as well to help with the infrastructure side of things. So this concept has also allowed us as developers to really kind of embrace the development of, or embrace infrastructure as part of our development practice. So, you open a pull request with your code. If you have some corresponding change you need to make the infrastructure to make sure that that code runs correctly, you just open the pull request at the same time. And that's kind of the definition of done, as you would say. So the entire team now has kind of learned these techniques and technologies, and has, now every one of the developers on the team is able to kind of work on the infrastructure side in addition to working on the development side. One other thing I want to note about GitOps that is, and I think it's more of as infrastructure as code in general, is that we can actually run tests against our infrastructure, whereas, in the traditional time you could potentially run automated tests against your website or something like that, but with treating infrastructure as code, now we can actually run things like unit tests against individual blocks of code, infrastructure code, to make sure that things are being configured the way we want them to be. So just wanted to make sure I highlighted that. But anyway, so the team is really come to enjoy using this, and and we leverage this tool Argo CD that Kushtan showed at the beginning of the talk to kind of help us visualize where things are in that kind of promotion and review process, and then allow us to also run tests and things like that as well. So it's kind of it's almost like Jenkins for your infrastructure, and it integrates really well with Kubernetes. So yeah, we just brought this back up to show some of the things I mentioned. So we have Terraform here as part of our deployment automation. We have our Kubernetes as part of our build, and then our deployment is running on EKS, which I don't know that we mentioned, but that stands for Elastic Kubernetes something.
What?
EKS, Elastic Kubernetes Service something? Something like that. Anyway, but that's Amazon's implementation of Kubernetes.
So before we roll back to the demo, we'll keep Logo Soup up for a second. Does anybody have any questions about the story, the technologies, before we start actually diving back into code? All right, well, I'm very sorry to bore all of you guys with some stories, but now we can dive right back into provisioning things. Thank you.
All right, so this is good, green is good. Looks like it has finished provisioning everything we had defined so far. So you can see that the cluster has been created. So I think before we go too far, let's kind of take a step back and look at what we did, because we just ran this thing that we didn't even review, so that's not very safe. So if we look in our main TF file, I guess, yeah, actually, maybe let me take a step back and can kind of go over some high-level Terraform concepts. So you can follow along too. There's this reference markdown that we can preview, and just kind of dumped a bunch of definitions here. So Terraform uses HCL, which is HashiCorp configuration language, to define its configuration. It's so yeah, the kind of main structure are these blocks like this, where you have a block type, a label, and then you have within the actual block, you have your configuration, which has identifiers and expressions. Resources in Terraform are kind of the core building block, and they are what describe your infrastructure objects. And those are, like this example here, your AWS VPC could be one of your resources. And they also kind of handle the definition of how Terraform is going to interact with the APIs for a given provider like AWS to be able to create your resource, destroy it, update it, or destroy and recreate. Data sources are kind of a special subset of a resource, which is really just for read-only data retrieval. So you can kind of just access them by the identifier of that data source, and then use other properties throughout as you need to define other dependencies on your other Terraform resources. And providers are kind of plugins that people can author that define how to interact with maybe a cloud provider, a SaaS provider, any API. So we'll be using the AWS provider as well as a Kubernetes provider, and but there's tons of providers for probably lots of tools that you use, like even Auth0, they have their own provider that you can use to define resources. And those are kind of typically found in the Terraform registry, which is, all right, don't do that, which is just where you can kind of, the webpage where you can search for your providers and then pull down the actual code from. And then, so providers also are what define the set of resources and data sources that you can work with. Then there's variables. Input variables are kind of the parameters that you can pass in when you're creating, when you're running Terraform, and you can change the parameters based on environment. So you might, have multiple variable files, like we have demo.tf files right now, but if you had, dev, staging, and prod, you could have different variables for those. Output variables are returned from a module to give you data that can be used in other modules or just reviewed. And local modules, or local variables are just kind of a convenience for naming. But one of the most important concepts is modules. They are kind of a container of multiple resources, and they allow you to organize your code and also can be published to public registries so that people can share modules as open source tools that people can kind of build off of, and we'll be doing that as well. So if we jump back into the main Terraform here, you can see we've defined our providers and the versions that we want for those. We've also set up this backend S3. So this is telling us, or telling Terraform that we want to store our state in S3. And Terraform state is kind of a very important concept. It's where Terraform pulls down all of the resources that it's managing and the identifiers and other metadata about those resources. And it kind of keeps this snapshot so that when it's comparing changes and applying things, that's kind of its source of truth of what exists out there. So here we're configuring the providers for AWS, Kubernetes, and kubectl. And then we're adding some resources. So the main ones being these modules to define a VPC. You can see that the source is this, this path which identifies it in the registry. So this is a public open source module that's maintained to kind of package up all the numerous resources that you'd need to define a VPC and give you a flexible way to configure it. And same thing for EKS. This is an open source module to set that up. And the configuration we have here is kind of pretty standard best practice, but example within that module. So I'm not going to go into the individual configuration too much. But this is all out there now, so let's go back to the steps. And we have a cluster out there, so the next step is to kind of verify that the deployment worked. One of the outputs of that EKS module is that it actually creates your kubeconfig for you. So you'll see in the files there, you should have something that starts with kubeconfig zsuite devcon and then 3 random letters. So to configure our the kubectl utility, we're just going to tell it where that config is. So we can copy some of that. And we'll just have to make sure it matches whatever your local environment has. So we'll just set that to OAJ. And then now I can run just kind of a general command in kubectl to, oh. Elab, I might need IAM authenticator. Looks like we have one dependency that you guys will likely run into as well. Is that, do you have the install script somewhere? All right, we'll have to get the command for that.
Can we just drop it in the README?
Sure.
All right.
Anybody have any questions while we update this one command?
Sorry, that was my fault. I totally had that in the setup script, and then I took it out because I didn't think we needed it. And so, my apologies.
The Terraform config file you were asking?
So like procurement has to be bucket or component AWS, there's probably stay away from
Yeah, it's like the prerequisites that we did Yeah, I mean, those, yeah, you could, maybe another team would do that, or, you know, you kind of, once you have one like S3 bucket provisioned, you don't really change that one too much. So I don't know, that's something that I guess we just do as a manual step before we create a new Terraform repository, but.
Okay, here we go.
While we're waiting for this, couple administrative things. The AWS accounts that you're all using today will be alive until about an hour after this session. Then it'll disappear. The repo that has all of these instructions is available for all of you moving forward at the URL. Feel free to use it. And at the end, we've got some slides with some contact information. So if you guys have any questions after this, feel free to contact us and we'll try to help you out.
This one? All right. So for anyone following along here, if you refresh the public Fintech DevCon README under step 2, there is a step 2 under step 2, I guess. So you can copy that command and let's see. So, okay, that looks good. And then let's try and run that kubectl namespace command again. Cool. So we're able to authenticate with the cluster, and you can see that we've got kind of the 4 standard namespaces that are created when you set up a cluster.
Sorry guys, I missed what did you have to do to
So
pass that on
yeah, if you go to the README in the Fintech DevCon, we just updated it, so you'll have to refresh. But yeah, there's step 2 here, this EKS utils curl install.
Oh, I see. I'm sorry. Still don't see it there. You just put that between the CTL get namespace.
Yeah.
Yeah, exactly. So before you run the get namespace, are you looking at it on the?
I'm still looking at Cloud 9.
Yeah. So if you do a git pull, it'll grab the latest.
Yeah. Should do that as well. All right, so let me see. Yep. Did that one work for you? Yeah. Cool. Yep. All right, so step 3 is to deploy Argo CD using Terraform. So this will basically install it into the cluster and give us a way within Terraform to kind of manage it easily. So the first step is to
You can go into the Fintech DevCon charts folder to run it. If you want to do it,
what is the to get the URL?
yeah, because right now we're in the Fintech DevCon.
Gotcha. So so Argo CD is going to use a separate repo, that charts repo, to look for its Helm charts. So we just need to get that repository URL that you forked as a part of the setup script. So if we go over to the Fintech DevCon charts folder, you can run that gh repo view command just to get that URL. Oh, that is, it should match your username here instead of ZSuite Tech. So
Yeah.
I'll just edit it and you guys can make sure that it matches. So if we go first to, you'll see in here this, there's this Argo CD folder within Fintech DevCon, which is a module. And if we go into manifests, there's this apps.yaml, and you'll see that that is pointing, this is basically defining an Argo CD application and which repository it should look for those charts. So if we replace that, I'm going to use mine. And you should be able to leave your target revision as head. But I think I changed mine, so. Let me just, yeah. All right, so yeah, save that file, and then let's check our, oops, sorry, tabs. And then the next thing we have to do is we have to go to the main Terraform file. And even though we've kind of got the module definition here, we need to use it within our, with our Terraform script. So you can just uncomment out on like line 176 so that we have module Argo CD, and that's just going to point at that subdirectory. So this is kind of an example of a best practice for Terraform where you kind of can move some cohesive configuration into a local submodule so that it's a little bit more organized, and you can see within the main Terraform for that submodule, it's the same structure as the root one that we've been working in, defining providers. And then we've just got a couple of things here where we're basically pointing at these manifest files to install them on the cluster using the kubectl provider. And this install.yaml is just what Argo CD provides for installation. You'll see it's about 4,000 lines, but you don't need to worry too much about that. And then we're also creating the namespace and defining the first application.
And that install was something that Argo provides like on their website. So this is not some massive thing that we wrote.
Yeah, never do that.
One other thing that's worth noting, in addition to the best practice of defining your submodules, it's also can be useful. Some of those main.tf files are pretty big. Nice thing about Terraform is it will actually just pick up any file with the suffix .tf in your directory. So if you need a way to organize your content into kind of sub pieces to make it easier to work with, that is also an option.
All right, so we've changed one of the modules that our Terraform script relies on, so we'll need to run init again. Do I have to do the one with the backend storage still, or is? Yeah, so if you just hit up to where you ran that last time, just find the Terraform init with the backend config.
Sorry to interrupt. I'm kind of confused. We want to update the repo URL on the apps.yaml file, right?
Yeah.
Since we forked the repo, should it have a different URL than what I got from that command?
Yeah, that command, I think that gave us the wrong URL. So it should be the one that matches your username, basically. So instead of Z Suite Tech.
Thanks, guys.
Yep, no problem. It's good. All right, so I'm going to run the Terraform init with that same backend config flag, and oh, I was in the wrong folder. Don't do that. So go back to your Terraform project, and then run that command.
While that's running, Real quick, Terraform, again, its goal in life is to generate your infrastructure. So remember earlier, Kushdan was talking about the state file. I have never felt like more of a magician in my career than messing with Terraform. Like you define a bunch of things in AWS, it goes off and runs, and it saves it, and it remembers, and then you just add a few new things to a Terraform file, and it figures it out and goes and provisions that. Like, incredibly minute things. So as Elov mentioned earlier, we do zero trust. So we would define resources and wait for a security exception and then add a single IAM policy to let that go through. And Terraform could find that single IAM policy or just a slight change in it and reapply it. Like, it's amazing. Sorry.
It is sweet. All right, so once that's initialized, we're just going to apply it again. So you can run the same apply command to make sure that you have those variables set. And the changes this time should be much less. So the first step it does is it goes out, it looks at its state file, and it will kind of try and update, from AWS, find any updates that happened outside of Terraform to just notice any drift, and then it'll try and run your new changes and compare it to what exists in the state file. So you'll see we have a lot of, most of these are just kind of the massive YAML files that we're looking at for these Argo manifests. So, but they're all green pluses. And I think that the summary at the end has 42 to add, 0 to change, 0 to destroy. So we can hit yes to approve those, and it's going to push that stuff out to the cluster. All right, hopefully it's wrapping up there. So to check that we've actually done something, we can just run, we can run that namespace command again. The kubectl get namespace, and we should see that we have a new one now. We've got Argo CD, so that's a good sign. And then to look at the resources within that namespace, we can just run that get all, specifying Argo CD as our namespace that we're going to look at. And you'll see we have a ton of things in here. So got basically all the stuff that Argo CD defined to install. We've got multiple servers, front end, back end, metrics, and the pods and containers basically that are running here to support the whole application. So everything says running. That's also good. And it should be out there. So unfortunately, this step 7, we did run into an issue with kind of port forwarding in Cloud 9. So I don't have a good way for you guys to do that. So we're going to have to kind of stick with the command line for most of this. But if you had run the port forwarding, you basically would be able to interact with the UI like I had shown up here. For this example, I'm just running on my local machine, not in Cloud 9. So we'll kind of skip most of that and continue on to step 4. So now that we've got a cluster and we've got Argo CD out there kind of ready to manage our cluster, we can actually deploy an app. So to do that, we can go to the forked Helm charts repo. So you guys can do this either kind of with the folder that you've pulled down here, or I think what I'm actually going to do is just within the GitHub UI. So you can see I'm on my specific fork here. we can edit the files in there, and it's just as easy. So what we're going to do is we're going to look in the apps/values file of that charts repo. So we can open that up here. And you'll see there's just a few variables that I've created here, or really you should only have two, to deploy Watchman and to deploy Watchman Ingress. And those are variables that are used by Helm charts. So I don't know if you're not familiar with Helm charts, they're basically a way to kind of add some logic and tokenization to your Kubernetes resource files so that you can, have templates and support different environments. So the one that we're going to look at is for this My Watchman app. And there's not much going on here. You can see all I've done is just kind of wrap the actual app with that variable. So once we enable it, it's going to deploy out this project definition. And so this is going to be the Watchman API. We're actually using Moov's published Helm charts from their repo. And we're going to create a namespace Moov and set up that app. So to go back to the actual step here, we want to set deploy Watchman to true. So go back to that values file. We can edit this and set that to true. So here's kind of a good example of the GitOps flow. We can make these changes in GitHub, propose them. You want to do it? No, it's my repo. I don't think you have access, but. So we can create a pull request, and then someone else would come along, see that these changes seem pretty reasonable, and we can merge that. So now, since Argo CD is kind of pointing at these repositories, it's detecting when changes occur. It kind of pulls it at some configured interval. And once it finds the new app, it will pick it up. So it might take a little bit, but let's see. We can see if it's out there. All right.
All right, let's take a moment here. So we've got Terraform. Terraform's job is to generate resources. We use Terraform to generate the Kubernetes cluster. Then we deployed into the Kubernetes cluster Argo CD, which is a continuous delivery package. So that's now running in the Kubernetes cluster, monitoring GitHub. When something changes in GitHub, Argo will detect the change and then roll out new containers into Kubernetes. So moving forward, if we have changes to our infrastructure, we make those changes in the Terraform files, code review those, and merge them. But changes in our applications, we're pushing into GitHub, and Argo is finding them and tearing down containers and building new containers in Kubernetes for our new code. It's a lot of layers of indirection. Just wanted to kind of clear that up. It's pretty complicated stuff, but it's pretty amazing once it's all working together.
I have a question. For things like deploy logs, would you implement at the GitHub layer then, or would you implement it at using like the Terraform or the resource block, actually doing the deployment?
What I heard, let me echo back the question, where are the deploy logs for all of this? Right now, they go into their isolated spot. So the Terraform logs are in Terraform, the Argo's in the other side. We are looking at consolidated logging, so then we would bring in not only those sets of logs, but we have Azure logs. We have all our different logs that we actually need to consolidate.
Sorry, locks, like a lock, like a lock safe.
Deploy lock.
Do you guys use deploy locks? So that's the first question, and basically the second question was, deploy lock be deployed at the Git level, like as part of your like
And you're talking like approver locks or like automated tests and.
So basically, it sounds like your code is automatically pulled into the Kubernetes cluster and redeployed. The deployment like triggers and redeploy all containers. There are certain times whenever you make the like cron jobs, something where there's like high load or high user availability where you don't want to deploy code, right? Do you utilize deploy locks? I guess that would be the first question.
Got it. I don't think we've implemented deploy locks for those types of controls yet, unless I'm misspeaking here.
Yeah, no, basically merging a pull request is equivalent to like triggering the deployment immediately. Yeah, yeah. But it is separate from like our code building process, right? Because so we'd have a separate kind of code and container building pipeline that would build our images and put them out into our container registry. And so that's kind of separate. So it's not like, so really like deploying new versions of code is done by updating what container version you want to use in those, like the Kubernetes deployment file, for example. So we can find the image definition in Moov, I think, and check that out too. So I think I see the Moov namespace here, and if we refresh, you can see that we've got the deployment and service and pod for Watchman running here. So we have an app, and if you were able to kind of log in, you would see that here, this is like that My Watchman. And actually, it's worth noting too, there's kind of this pattern with Argo CD where they have they call it like the app of apps. So we kind of created that initial parent app, and then that app will have child apps defined under it, which are their own kind of specialized like custom resource definition in Kubernetes. And then when those are actually created, it kicks off looking at these other apps. So you can kind of think of this as the parent way to manage all the apps within Argo CD. And this is what Watchman looks like when it's deployed. So it's got kind of all of your Kubernetes resources visualized here. And you can even kind of browse like the pod logs and see just general events. Like if you did have an issue with the deployment, things would be red and broken, and you could kind of debug it here as a starting point. All right, so we can also test the API out. If we find the pod, yeah, let's try that. All right, so we're just searching for pods with that name, and we can copy that pod name. And then we're going to forward all of the local traffic on port 8081 to the pods port of 8080. And I think we'll need to pop open a different terminal here.
And the reason that we use those, just a quick comment on that, the reason that we use 8081 is because Cloud9 automatically knows kind of how to expose apps running on ports 8080 through, I think, like 8083. So that's why we expose it on that port. And in fact, we tried to get it working with Argo CD on port 8080 and didn't work. And we ran out of time trying to figure out why. So anyway.
This is not expected.
Oh, we ran into that one time with
Yeah, we did run into that. Well, Does anyone know what this means? Enter host password for user, RI.
Oh. User RI. Oh, because you're using the PowerShell command, that's why.
I've been found out.
So just do, you don't need anything.
All right. Good work, team.
Yeah, we're Windows shop, so we use PowerShell a lot. So.
It's, all right.
Or we're a .NET shop. We no longer much of a Windows shop.
All right, so this is much better. You can see we've got basically what we've asked the Watchman API for is kind of the latest downloads and the summary there. So we downloaded the kind of SDN OFAC list, and there's 9,000 SDNs, alt names. So that's good. It's working. So the last step here is instead of having to port forward your stuff, it would be nice if we actually could hit it from a public endpoint. So to do that, we can deploy an Ingress for the Watchman API. And so the first step to do that is we need to actually install the ALB Ingress controller to the cluster. So if we go back to the main file here.
So while Dan's doing this, a comment on this. So one cool thing about the way that Kubernetes handles Ingress is it actually, through these Ingress controllers, is able to kind of interface directly with the cloud providers. So, so even though we're deploying through Kubernetes, Kubernetes actually, there's a layer that is able to talk to AWS itself and kind of provision things in AWS as part of our Kubernetes deployments. So ALB, for those that are less familiar with AWS, is Application Load Balancer.
All right, so you can uncomment that section, and similar to the previous module, we'll have to do the init again. So you can just find that command, make sure you get the one with the state configuration and that you're in the right folder. And all right, we're good. And now if we run apply again, it's going to deploy that as well. And this hasn't created any new kind of resources that are going to be used for the app. It's just kind of deploying the controller out in Kubernetes so that it can know what to do with ingresses that you deploy.
Yeah, so to my point from before, we're not actually using Terraform to tell AWS to create the load balancer. We're just telling Kubernetes to go create an Ingress and use AWS to create the load balancer. So it's a little bit of a mind, mess.
Yeah, and it is. Well, yeah, and it's nice too. You can kind of all these things that we have been creating do exist in AWS, so you can go out and find them. Right now, you'll see that we don't have any load balancers, but we should see that change shortly. Still going.
And I just looked at the clock. You don't
Yeah.
have much time left.
We don't.
No. How many more steps do we have? Is this the last one?
This is pretty much it. So we deploy the Ingress, and then we should have an endpoint. Should we stop here? Any questions, or do you guys? I don't know.
I have a question. I feel like this is really naive, but I'm just a little confused about how, say, we want to uncomment something out of the Terraform file. We do that in Cloud 9 in our fork repo, but then when we want to change the values that we handle, we actually have to go into GitHub and edit there.
Right.
get those out to the galleries. That's,
Yeah, so
help me understand that. I don't.
yeah, so that's kind of just the way that we're managing and deploying Terraform. We're not using, it's not set up for any kind of,
It's pointed at the repo.
yeah, so like we're manually running the Terraform files that we have locally and pushing those changes out to the environment. So as a second step after that, you would need to kind of commit those changes and push those up so that, you don't have stuff that you did that's only locally. If you could also, some people, will have a kind of a build pipeline for their Terraform changes as well. And so they'll do a pull request with their Terraform changes, and that will actually run and deploy out to the environment. And you just need to make sure that, if there were changes that you didn't want, like if any deletions of resources you weren't expecting, you'd need to kind of build in those checks. We haven't really, our process isn't that mature for this right now to have it all automated, so we're kind of just manually reviewing it and deploying it as we promote through the environments. But yeah, so that's why there's one kind of local set of files that is okay to not do pull requests for, and then there's the Helm charts files, which since we rely on Argo CD kind of pointing at that public URL for the repository, that's why we need to actually do the pull request so that it can get the source from there.
So if we updated those files on our Cloud9 machine, we wouldn't see that unless we pushed it.
Exactly. Yep. Yep.
Yeah, and on the Terraform deployments, we still use a GitOps process. We just do that actual, the final, press of the button is manual because we haven't yet configured it to show up in Argo for doing the Terraform deployments. So, but we still promote to production branch, and then that's the trigger to let us know, we can deploy this, review the plan, and then hit yes.
Yeah.
Yep. So let me go back. When something could either be provisioned in Terraform or in Helm, which one do we choose and why?
Yeah, I think we're still figuring that out a little bit. I think that I think using Helm, if we can, has kind of been where we've leaned. Just because it kind of keeps things, at least Argo CD is kind of hooked up a little bit better in our process, so we kind of get more for free if we define it in Helm. And if it's just like a Kubernetes native thing, then having all of our Kubernetes specific things that we can manage within Argo CD has been working out so far. But yeah, I do think that there's a balance there. It really getting the minimum setup Argo CD deployed so that we can then use it to manage all the other things is kind of where I would draw the line of do that in Terraform and then kind of pass off any app-specific things to Helm if you can.
Yeah, and I mean, if it's stuff that we're deploying, we use RDS, which is a relational database service for those less familiar with AWS, which is kind of a managed version of database provider, so we don't have to run it in Kubernetes ourselves. So for that type of thing, there's I don't think there's a way to do it through Helm, so so that's the type of thing that we still use Kubernetes for. And
Terraform.
we have not hooked it up yet, or sorry, to Terraform, that's what I meant to say. We have not hooked it up yet, but basically the way that you can actually hook Terraform into Argo CD is it basically just spins up a container in Argo CD with Terraform pre-installed, and then it would kind of run through the exact same process it would do with Helm, except it has to, actually spin up a container to be able to use the Terraform tooling.
All right, excellent. Any other questions? I can go to the last slide. We do have one more slide.
Oh, God. Nope.
There we go. So if you have any questions moving forward, all of us are on the Slack, on Moov Slack, so you can find us on Moov Slack. Here's all of our Twitter usernames. Feel free to find us on Twitter or an individual email that we'll be monitoring for a little while after the conference. Feel free to email that until it bounces, and we'll do our best to respond. And after that, best place to find us will be on the Moov Slack and Twitter. Thank you, everyone, for your time. We really appreciate you coming and joining us today.